Here we have IIT JEE Main mathematics problem. Okay, let's go to the question. Let alpha and beta be the distinct roots of 2x square positive cosine theta times x negative 1 equals to 0. Theta belongs to the interval 0, 2 pi. If m, small m and capital M are the minimum and maximum values of alpha to the fourth power positive beta to the fourth power, then 16 times capital M positive small m is equal to. So our aim is to find the value of this expression. 16 times capital M positive small m, and capital M is the maximum value of this expression and small m is the minimum value of this expression. And for this quadratic equation, we have two roots, alpha and beta. Both of them are different. So because the information clearly says alpha and beta be the distinct roots of the given quadratic equation. Okay, now let me write the given quadratic equation as it is. That is 2x square positive cosine theta times x negative 1 equals to 0. Okay, now let's consider a quadratic equation in standard form. That is ax square positive bx positive c equals to 0. For this quadratic equation, we have formulas to find the sum of the roots and product of the roots. So the formula to find sum of the roots is negative b over a, and the formula to find the product of the roots is c over a. And the question says for this quadratic equation, the two distinct roots are alpha and beta. Then when I add alpha and beta, this represents the sum of the roots. Sum of the roots is equal to what? Negative b over a, that is negative. Actually, this b is the coefficient of x and this a is the coefficient of x square. In our quadratic equation, the coefficient of x is cosine theta. So we have to write cosine theta in numerator. In denominator, we have to write the coefficient of x square, that is 2. Okay, now I got alpha positive beta. Now let's find product of the roots. Product of the roots means we have to multiply the two roots alpha and beta. That is equal to c over a. C is a constant term. So here the constant is negative 1 and a is the coefficient of x square, that is 2, negative 1 over 2. Now I got the values of alpha positive beta and alpha beta. So using these two values, I am going to evaluate the value of this expression alpha to the fourth power positive beta to the fourth power. For that, we have to consider the two identities in algebra. Okay, let me continue on the next page. Okay, I am going to write the two required identities in algebra. That is, the first one is a square positive b square equals to a positive b the whole square negative 2ab, and another identity is a to the fourth power positive b to the fourth power equals to a square positive b square the whole square negative 2a square times b square. Okay, now what I'm going to do is I'm going to use the second identity over here by replacing a by alpha and b by beta. Okay, let me write it over here. Then I'm getting alpha to the fourth power positive beta to the fourth power equals to alpha square positive beta square the whole square negative 2 times alpha square times beta square. Okay, we have to evaluate this expression separately using the first identity over here. So in this first identity, I have to replace a by alpha, b by beta. Let me do it. Then I'm getting alpha square positive beta square equals to alpha positive beta the whole square negative 2 times alpha beta. Okay, in this one, already we know the value for alpha positive beta, we got it. That is a negative cosine theta over 2. We can plug in this for alpha positive beta over here. That is a negative cosine theta over 2 the whole square. And for this alpha times beta also, already we got the value. That is negative 1 over 2. We can plug in negative 1 over 2 for this alpha beta. Let me write it. So here this 2 will cancel out. And when I square negative cosine theta, it will just become cosine theta the whole square, because whenever I square negative sign, it will become positive. When I square the denominator 2, it will become 4, and here negative times negative will become positive 1. Okay, now I got the value of alpha square positive beta square. I can plug in this value for alpha square positive beta square over here. And also we can find the value of this 2 times alpha square beta square. Let me do it. 2 times alpha square times beta square. So here two terms are multiplied with the same exponent 2. Whenever two terms are multiplied with the same exponent, what we can do is we can write the exponent in common. Then I'm getting 2 times alpha beta the whole square. So then 2 times, already we got the value for alpha times beta, that is negative 1 over 2 the whole square. Then I'm getting 2 times. When I square this negative 1 over 2, I'm getting a 1/4. Then 2 goes into 2 1 times and 2 goes into 4 2 times. Then I'm getting 1 over 2. So the value of this 2 times alpha square times beta square is just 1 over 2. Okay, now I can plug in this value for alpha square positive beta square over here, and 1 over 2 for this 2 times alpha square times beta square. Okay, let me continue. Alpha to the fourth power positive beta to the fourth power equals to, we get cosine theta the whole square over 4 positive 1 the whole square negative. The value of this 2 alpha square times beta square is just 1 half. Okay, now I got the value of alpha to the fourth power positive beta to the fourth power. Okay, let me go over the information again. So this small m represents the minimum value of this expression, and this capital M represents the maximum value of this expression. So here once I get the minimum value and maximum value of this expression, I can know the values of this small m and capital M, and I'll be able to evaluate the value of this expression 16 times capital M positive small m. Okay, how can we get the minimum value and maximum value of this expression? So for that, let me consider this particular part of this expression, that is cosine theta over here. What is the minimum value of cosine theta and maximum value of the cosine theta? We know that the minimum value of cosine theta is -1 and the maximum value of cosine theta is +1. So better I can write this one on a number line. Okay, here the minimum value is -1 and the maximum value is +1, and in the middle we have 0. So this is the range of values we have for cosine theta. Okay, here to get the maximum value of this expression alpha to the fourth power positive beta to the fourth power. So here what we can do is we can use the maximum value of cosine theta, that is 1. We have to plug in 1 for cosine theta over here. When I plug in 1 for cosine theta over here, that is the maximum value of cosine theta. So I'll be getting the maximum value of this expression over here on the right side. Okay, to get the minimum value of this one, what do we have to do? So many students may think to get the minimum value of this expression, we have to plug in the minimum value of cosine theta, that is -1. Okay, just think about it. When I plug in -1 for cosine theta over here, what will happen? So -1 will be square, so then it will become +1. So when I plug in 1 for cosine theta, that is maximum value of cosine theta over here, that is 1 square. 1 square is just 1 over 4 +1 the whole square. Okay, whatever we get, we can simplify. Even when I plug in the minimum value -1 for cosine theta, still I'm getting the same thing, because it is square, then it becomes a positive value. So when I plug in any value from 0 to between 0 and 1, and any value between -1 and 0, so the value of this part is the same. Because of the even exponent, it will become positive, whether we plug in a positive value for cosine theta or negative value for cosine theta. But I'm pretty sure to get the maximum value of this stuff, I have to plug in the maximum value of cosine theta. That is, I have to plug in 1 for cosine theta over here. To get the minimum value, what I have to do is I have to plug in this 0 for cosine theta, so that I'll be getting the minimum value. Okay, let me continue on the next page. This is a step we have had on the previous page. Okay, now to get the maximum value of this expression, that is capital M, what I have to do is I have to plug in 1 for cosine theta. That's the maximum value of cosine theta, as we discussed earlier. Then I'm getting 1 square over 4 positive 1 the whole square and -1 over 2. Then I'm getting capital M equals to 1 square is just 1, that is 1/4 positive 1 whole square -1 over 2. Now let me add this fraction and an integer. For that I have to multiply this integer 1 by 4. Then I'm getting 1 positive 4 over 4 the whole square -1 over 2. Then I'm getting capital M equals to 5/4 the whole square and -1 over 2. Okay, let me continue over here. So then I'm getting M equals to, when I square the fraction 5/4, I'm getting 25 over 16 -1 over 2. Now I multiply both numerator and denominator of this fraction by 8, so that I'll be getting the same denominator for both the fractions. Then I'm getting 25 over 16 -8 over 16. So now we have the common denominator 16. Then we get 25 -8. So finally the maximum value of this expression, that is capital M, equals to 17 over 16. Okay, now I got the maximum value capital M. Okay, now what I have to do is I have to get the minimum value. So as we discussed earlier, to get the minimum value of this expression, I have to plug in 0 for cosine theta over here. Okay, let me do it. Then I'm getting, when I plug in 0 for this cosine theta, it will be 0 square. 0 square is 0. 0 divided by 4 is still 0. Then 0 positive 1 is just we get 1. That is 1 square -1 over 2. We get M equals to 1 square is just 1. 1 -1 over 2 equals to, when I simplify this one, I'm just getting 1 over 2. So the minimum value of this expression alpha to the fourth power positive beta to the fourth power is just 1 over 2. So that's the value of small m. But our aim is to find the value of the expression 16 times capital M positive small m. So here 16 times, the value of capital M is 17 over 16. Positive small m is 1 over 2. Okay, now what we can do is we can distribute this 16 to this one and this one. When I do so, I'm getting 16 times 17 over 16. Positive 16 times 1 over 2. So here 16 will cancel. 2 goes into 2 1 times and 2 goes into 16 8 times. Then I'm getting 17 positive 8. So finally I'm getting 25. So the value of the expression 16 times the capital M positive small m is 25. Now let's go to the question. We find 25 in answer choice B. The correct answer choice for this question is B.